finding the molecular formula. Moving from the empirical formula to the molecular formula. Now that we have found the empirical formula of a compound from the percent composition, is there any way that we can determine what the molecular formula actually is? The answer is yes, but rather than just telling you how to do it, let's think about the issue first. What is the empirical formula? It shows the lowest whole number ratio of the atoms in a compound. So how is that related to the molecular formula? Remember that it is possible for many compounds to have the same empirical formula. The empirical formula shows the lowest whole number ratio, and the molecular formula has the same ratio, but possibly with higher numbers. Let's suppose we have an empirical formula of C2H3. Then the molecular formula could be C2H3. The empirical and molecular formulas can be the same. C4H6, C6H9, C8H12, C10H15, or any number of other possibilities that have the same ratio, 3 hydrogens to 2 carbons. So, how do these molecular formulas relate to the empirical formula? If we look at the subscripts of the molecular formulas and the subscripts of the empirical formula, what we see is that C2H3 equals 1 times C2H3. C4H6 equals 2 times C2H3. C6H9 equals 3 times C2H3. C8H12 equals 4 times C2H3. And C10H15 equals 5 times C2H3. This means that the molecular formula is a whole number multiple of the empirical formula. Specifically, C2H3 is 1 times the empirical formula, C4H6 is 2 times the empirical formula, C6H9 3 times the empirical formula, C8H12 4 times the empirical formula, and C10H15 5 times the empirical formula. So we can find the molecular formula if we can find the correct whole number to multiply the empirical formula by. But how are we to find the correct whole number? With the empirical formula alone, we cannot. But if we have more information, we can. The additional piece of information we need is the molar mass of the actual compound. How does that help? Let's suppose, for the sake of argument, that the molecular formula of our compound is C8H12. This is 4 times C2H3. The molar mass of the compound is 8 times carbon, which is 8 times 12.011, or 96.088. 12 times hydrogen, which is 12 times 1.008, or 12.10, which needed to be rounded to 4 sig figs, and we add them to get 108.19 grams per mole, which is only good to the second decimal place. The empirical formula molar mass is 2 times carbon, or 2 times 12.011, which is 24.022, 3 times hydrogen, which is 3 times 1.008, or 3.024, and we add them to get 27.046 grams per empirical formula. When we multiply the empirical formula molar mass by the same 4 as in the formulas, we get 108.184, which is essentially the same as the molar mass of the compound. So, if we were to take the molar mass of the compound and divide it by the molar mass of the empirical formula, we would get the multiplier to convert the empirical formula into the molecular formula. Since we already have the empirical formula, we can easily get the molar mass of the empirical formula. So the additional piece of information we need is the molar mass of the actual compound. Example 1. A certain compound is found to have an empirical formula of C2H4O. If the molar mass of the compound is found to be 132 grams per mole, determine the molecular formula of the compound. The empirical formula molar mass is 2 times carbon, 2 times 12.011, which equals 24.022. 4 times hydrogen, which is 4 times 1.008, which equals 4.032. And 1 times oxygen, which is 1 times 15.999, which equals 15.999, which equals 44.053 grams per empirical formula. If we divide the given molar mass by the empirical formula mass, we get 2.996390711, which is close enough to a whole number to round off to a 3. Then the molecular formula is 3 times C2H4O, which equals C6H12O3. Example 2. A certain compound of carbon and hydrogen is found to have an empirical formula of C3H7. If 25.2 grams of the compound are found to be 0.293 moles, determine the molecular formula of the compound. In this case, we are not given the actual molar mass of the compound, but we are given enough information to calculate it. Molar mass is grams divided by moles, which is 25.2 grams divided by 0.293 moles, which gives us 86.0068259 grams per mole. Now, the empirical formula molar mass is 3 times carbon, or 36.033, and 7 times hydrogen, or 7.056, which equals 43.089 grams per empirical formula. Dividing the molar mass of the compound, 86.0068259, by the empirical formula molar mass, 43.089, gives us 1.99602749, which can be rounded off to a 2. So the molecular formula is 2 times C3H7, which equals C6H14.